Hi everyone. So in this video, let's see about another interesting topic about the equilibrium moisture content. So as we have seen in the previous video about the drying and its concept, so in that drying we had already discussed about the the drying stages. That is the first falling stage and the second falling stage, and what is the constant drying time and the constant second constant drying period, everything, etc. So this equilibrium moisture content is also an important phase that occurs during the time of drying, that is during the study of the rate of drying. This EMC plays the major role. So coming to this, just like a recap, drying is already we have seen it is defined as the removal of small amounts of water or other liquid from a material by the heat application, or it is nothing but the removal of all or almost most of the liquid by supplying heat to cause a thermal vaporization technique. So the difference between evaporation and the drying. So here in drying, final product is a dry solid. In evaporation, what happens is final product is concentrated solution or suspension or any wet slurry. So here in drying, the vapor is removed at temperature below its boiling point only, but in evaporation the water is removed at its boiling point only. Okay, so this is the basic difference between drying and evaporation. So where we can apply this drying, it is applied for the preservation of drug products or even during the preparation of bulk drugs. So in the preparation of bulk drugs, drying in the final stage of processing, like for drying, like spray dried powders or powder extracts or dried form of any drugs can be used for the drying. And even why it is applied is mainly to prevent the deterioration. It is been mostly adopted. Okay, coming to the EMC. So equilibrium moisture content is nothing but, so at equilibrium what will be the status. So we have a wet mass in the picture. So vapor pressure of wet mass will be equal to the vapor pressure of the atmosphere. So considering the water vapor pressure at the wet mass and that of the atmosphere will be equal at an equilibrium stage. So we can conclude conclusion that the how much amount of water will be present in the particular solid or material will be equal to the equilibrium moisture content. So it is nothing but the amount of water that is present in the solid which will exert a vapor pressure equal to the vapor pressure of the surrounding atmosphere. Okay, so this is the definition of the EMC. So equilibrium moisture content in a wet mass is shown below, as I already explained. Here the temperature and the humidity of the air that is kept constant so that the solid may absorb of loose moisture. Okay, so when for example they are giving a difference between the desorption and the sorption. Okay, so when the air that is of constant temperature and humidity is continuously passed over solid containing moisture more than the equilibrium moisture content, this phenomenon is called as the desorption. So in the first picture, when we see in the desorption, moisture in the solid is like what happens is that greater than the equilibrium moisture content of the solid, that is the moisture will be escaping out from the particular solid material, so that we call it as this desorption. And in the sorption, what happens is the moisture content in the solid, that is both having a constant temperature and humidity, what happens is lesser than the equilibrium moisture content of the solid. So it is continuously passed over the solid containing moisture is less than EMC. What happens is that that particular solid will absorb the water continuously till EMC is reached. So in order to reach the equilibrium moisture content, if there is an escape of moisture, we call it as a desorption. If there is an absorption of water or the moisture until the EMC is attained, is called as the sorption. So this phenomenon is called as a sorption. So what is the measurement of EMC? That is how we can measure that the particular wet mass or the solid material has attained its EMC is nothing but the solid samples are placed in a series of closed chambers such as desiccators, that is without any interference of the air. We have to keep the solid sample in a closed chamber. So each chamber should consist of solution, that is a desiccant, where samples are exposed to different humidity and conditions. So this exposure is continued until that material attain a constant weight. So now we have to take a difference in the final and the initial weights. Then we can calculate the moisture content with the final and initial. The moisture content is measured twice, before keeping the material into the storage bin and after taking the material out. So it's from this way we can calculate the EMC. Next, during the storage time, the material may either lose or it may gain the moisture. That is, gaining or losing the moisture. Equilibrium moisture curve is drawn by taking into consideration the relative humidity on the x-axis and moisture content on the y-axis, where this can be applied. So this EMC curve permits the selection of experimental conditions to be used for drying the product. So drying should be stopped when the moisture content reaches the level of the EMC. So it indicates that when particular material attains EMC, we have to stop the process of drying. Over drying can be avoided because over dried product will quickly regain the moisture from the atmospheric conditions. And next, if the moisture content is to be reduced, the RH of the atmospheric air must be reduced as the first step. This can be done either mechanically or in a large scale by using any AC system, and on scale desiccators can be used on the small scale in order to control the RH. So factors that affect the EMC are the nature of the material and the nature of the air. So first is the nature of the material. So coming into this, material plays a major role. So non-porous insoluble solids have an EMC of particularly 0. That is like zinc oxide or the talc. For fibrous or colloidal organic materials, the EMC values are more high and maybe it may vary. For example, cotton fabric has a very high equilibrium moisture content under normal atmospheric conditions, that is moisture from 10 to 15%. For porous materials, if we see, EMC values are much higher and variable. The water may be held in fine capillaries that have no access to the surface. So this is the difference between the what type of material has to be chosen. Okay. Next factor is the nature of air. So for air of 0 humidity, EMC of all materials will be 0 only. So as the temperature of the air increases, the EMC, particular solid load EMC also will decrease. Okay, so these are the two factors that affects the EMC. Thank you.